Hello, my name is Alejandro. For exam number 4, I'm gonna be working with homework 25.3. With me, I have my tablet, a pen, and my calculator. Let's begin. Part A. Some airlines use wires of aluminum resistivity 2.75 times 10 to the power of minus 8 ohm times m. Write down Cooper to reduce weight. The potential difference between the ends of an aluminum wire 32 meters long is 1.55 voltage. When the wire carries around 1.20 find the electric field magnitude inside the wire. Okay, for this one, let's see what is given to us. Um, Resistivity. Length is given to us. P is also given to us. I believe I is given to us. We need to find the electric field magnitude. Okay, there is a relationship between all what we have here. We're gonna use the formula E. It's gonna be and we're gonna plug in all the information we have. And that's the answer for our electric field magnitude. Let's move on to part B. Find the resistance of the wire. Okay, we know resistance is given by the formula that is used. Let's distribute. Mm, Check the numbers. Yes. We are ready to get the answer. It will be resistance will be Let me double check that answer. Yeah, that's the right answer. Okay, for C. Find the cross-sectional area of the wire. The cross-sectional area of the wire. We know the formula resistance. Do we have everything we need? There is a relationship here to find the area. We have the answer for resistance. So we're gonna distribute to solve for A. Resistivity. Will be 75. Length, we know 32 meters. Resistance, we got in part B, and it's 1.29. Okay. That's the area. Double check. And that's correct. And here concludes our first exercise. Part D. When a current of 0.218A is present in a wire 25 meters in length with cross-sectional area 8.19 times 10 to the power of minus 7 meters to the power 2. The electric field inside the wire is 6.50 times 10 to the power of minus 3 Vm. What is the resistance of the wire? Okay, what do we need to find? Resistance. Let's see what is given to us so we can find a relationship. Current is given to us. length, area, electric field. We know we have to find resistance. Formula for resistance we're going to use is this is not exactly the regular formula. Um, um, I believe we have everything. We just need to plug in to find the answer. Roughly 0.74 ohm. Let me double check this. Yes, I believe that's correct. Okay, part E. What is the resistivity of the material of which the wire is made? Resistivity of the material which the wire is made. Okay, we know the formula for resistance is there is a different formula here that we're gonna use is resistivity times but we need to find resistivity, so we need to distribute. I believe we have everything we need to solve this one. So we are gonna just plug in. We found it before. Area. check out the numbers. I'm not missing, making sure I'm not missing anything. That seems about right. Okay. I believe this is the answer. For resistivity, no resistance, there are two different things. Well, let me double check before I move on. Yes, I believe this one is correct. Okay, part F. Two wires of circular cross section are made of the same metal. Wire 1 has a radius r and length l. Wire 2 has radius 2r and length 2l. The potential difference between the ends of the wire is the same for both wires. Find the ratio of the resistance of wire 2 to a resistance of wire 1. Okay, we need to find the ratio of resistance. Wire 2 to a resistance of wire 1. Okay. This is what we need to find. Which formula we're gonna use? I believe we can use okay, given that we were given area and length, we're gonna use the same formula that we use on part E. We need to work with the two wires and then find the ratio. For the first one, for the first one, we know the length is just L and the area is PR to the power 2. Now, for R2, we have 12, and the area is gonna be 2. Cancel the 2 and the 4, we get R2. Now, if we were to do R2, the ratio R2, and the answer will be 1/2. This is cool information that probably we're gonna need in the next exercise. Okay, find the ratio of the current of the wire 2 to a current of wire 1. Current. Okay, we need to find current. What relationship we can use here? We know the formula. This is exactly what we're gonna use to find this one. We know the hmm, okay. We have to distribute this one because at the end of the day, what we need to find is I, which is the current. So we're gonna use the form. We are gonna distribute this formula to look like this. Okay. One thing about this one was given as an information was given to us that mm, the potential ends, the potential difference between the end of the wire is the same for both wires. That means that this one is equal to this one. That's relevant because we're gonna try to cancel them. Okay. Two. Mm, okay. We can cancel this. We know mm, actually we made a mistake here. We know R R2 is 1, R1 is 2. Because we did it on the previous exercise. Cancel. The answer for this one is 2. Okay, part H. Find the ratio of the current density of wire 2 to the current density of wire 1. The rate of the current density of the wire. Okay, for this one, we're gonna use this formula. We need to find this. We are gonna do the same operation that we did before. RE, the area was pi square 2. For this one, the area was if we were to find the ratio, we would say it would be 1/2. Is that correct? I believe that's correct. Part I. Find the ratio of the electric field magnitude of wire 2 to electric field magnitude of wire 1. So basically, we need to find the ratio, which will be wire 2 of wire 1. For this, we're gonna use the same formula that we use in part A over here. And once again, you're gonna separate this. We have all this information, it was given to us. We have to remember the V1 is equal to V2, and that's a condition. It was given to us. And it was just length. And for this one, twice the length. Now we can find the ratio. We can cancel those, they are the same. And the answer is 1/2. And that concludes our third exercise. Okay, last one. Part J. The current in a certain wire at 20 degrees Celsius is 2.40 A, when the potential difference between the ends of the wire is 1.15 V. If the wire is heated to 80 degrees Celsius and the potential difference remains the same, the current decreases to 2.08. What is the resistance of the wire at 20 degrees Celsius? What is the resistance of the wire? Okay, resistance is what we need to find. What is given to us? Recognize the formula. Current at a certain wire, current is given to us. But at 20.0 degrees Celsius. B is given to us. Also, is given to us current is gonna be 2.00 at different temperature. It's gonna be relevant. Okay, but the question is, what is the resistance of the wire at 20 degrees Celsius? We can work with this. We have all the information that we need. There is a relationship here. We are gonna use this formula. But first we need to distribute. Um, 20 degrees heat. Let's calculate this. I believe this is correct, but let me double check. That's correct. Parquet. What is the resistance of the wire at 80 degrees Celsius? Okay, for this one, we're going to use the same formula. Once again, we have all the information. Um, at 80 degrees, it's going to be 2. That's the resistance of the wire at 80 degrees Celsius. Let me double check. It could be wrong. I believe this is correct. Okay, part L. What is the temperature and coefficient resistivity for the material of which the wire is made? Okay, here we need to have, we're gonna have to use formula here. We're gonna use, it's gonna be R. Um, coefficient of resistivity is what we need to find. But I believe we have everything we need to solve this one because we have the resistance of the wire from part J and K, and we're gonna plug in. And we also have the T. It's gonna be 0.75. 80 minus 20. And that's the final answer for the coefficient of resistivity. And that concludes my exam number 4.